Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Yes, everybody. So everybody just confirm audio and visual quality, everything is clear so that we can proceed with the session. Until you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session. In this session, we will be doing a complete coverage of economic load dispatch, which is one of the important area for your subject power system. You can understand every year approximately 2 to 4 marks you will get in the gate examination as far as this particular topic is concerned. It is a good scoring topic because almost every year you see you are getting questions from this area, and it is very easy also. It's quite mathematical also. So if you have a good command, confidence over the basic concept, then you can deal with the questions very easily. So let us start with the session. This session is going to be approximately 1.5 hours. The duration is going to be 1.5 hours, and we will try to complete the understanding part of economic load dispatch, and at the same time we will do significant number of problems also, so that you feel confidence also while solving the real problems, that is problems in the gate examination. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh, as you can see on the screen. I have 11 plus years of teaching experience, completed MTech from BYJU in 2010, written a couple of books, and these are my areas of expertise. You all must be aware that recently, 17th of January, we have started with the Master MSQ series, and this series is going to be a game changer for all of you because you can understand that MSQ is going to be the key pivot around which now gate examination is conducted. Good evening, Sudarshan. How are you? Welcome to the session. So this series we have started for electrical, electronics, instrumentation, computer science, all the branches. Already the classes have started from 17th of January. So subscribe to BYJU'S Exam Prep so that you do not miss any of these sessions. BYJU'S Exam Prep is going to conduct a scholarship test on 22nd of January. Do not miss this date. The timing is 12 p.m. in the afternoon. But for this scholarship test, you have to get yourself registered. Okay. And in this scholarship test, you may get up to 90% scholarship for your GATE and engineering services preparation in BYJU'S Exam Prep. So it is going to be a big opportunity for all of you. I would say do not miss this opportunity. Now, two legendary faculties, Rakesh sir and Ankit Joshi sir, they both are coming with a non-stop maths marathon session where you can score 13 marks in just 2 days. The session is going to be on app and from 21st and 22nd January. So everybody just quickly hit the like button, hit the bell icon and subscribe to BYJU'S Exam Prep so that you do not miss any of these important sessions. Good evening everybody, welcome to the session. So let us start with the basic idea. What is the optimization problem? I'm going to start with the optimization problem. Why we are doing the economic load dispatch. So first we will have what is optimization problem. Everybody just tell me, are you comfortable in English? If you want little bit Hindi also, then you can ask me. I would give you translation also, no problem. Good evening everybody. Let us first understand what is this optimization problem, because the solution you are providing, that is economic load dispatch, first you understand the problem. What is the problem? So assume this is our power system. In this power system, suppose we have n number of generators. Okay. These generators are going to have some generation which is contributed to the total load demand, yes or no? These generators will be generating P1, P2 and up to Pn, some real power which is being finally supplied to the load. So they all are contributing according to some strategy. Okay. Now suppose suddenly some extra load demand is coming on the system. Some extra load demand is coming on the system. Now we have to allocate this extra demand to these N generators. Now the problem is how to allocate and to which generator to allocate. How I am going to know whether I should allocate how much generation to G1, how much generation to G2, how much generation to G4, so that I can meet the increased demand, that is PD plus delta PD. This problem is called the optimization problem. This problem is what we are going to solve with the help of economic load dispatch. So everybody just give me a thumbs up whether you are able to understand the optimization problem or not. I hope it is clear for everybody. The second one is the concept of unit commitment. The concept of unit commitment. What is the concept of unit commitment? Again, suppose there is a power system. In this power system, suppose there are N generators, and these generators are having P1, P2 and suppose Pn generations contributing to the total load or demand connected to the power system. Okay. Now, when a particular generator, suppose this is a new generator, this is N plus 1th generator, this generator also want to come into this group of parallel operation of generators, and this generator is also going to be taken into this group of generators. The moment this generator has to be included here, there should be a minimum generation which is available all the time by this generator. Yes or no? When it is coming into this group of generators operating parallel, there must be a minimum generation ensured which is available all the time, so that whenever the demand is coming, we know that this much minimum generation is available with this generator, and this is what we call as unit commitment. Is it clear, everybody? Just tell me yes or no in the comment section. Are you able to follow this? Just tell me yes or no. I am telling you in the most simple way. If you read it from the book, this is not the time to revise it from the book. It's better you attend this session. Within 1.5 hours, I am going to completely finish this particular topic along with the questions also. So this is the problem of optimization problem and unit commitment. Now let us talk about important curve, that is this curve is called as input energy curve or fuel cost curve. If you plot this curve is going to be something like this. This is going to be Fi, Pgi. This is the input energy. It is going to be in mega kilocalorie per hour, or it is going to be the cost function. This cost function we are defining as Ci Pgi, because we are talking about the ith generator. Okay. and this is going to be the power generated PGI. If you see the variation of this input energy or fuel cost, it is going to be concave upwards. Concave upwards. Something like this. Okay. Now below this and beyond this, generation is not possible. Why? Because generator is going to have the minimum and maximum power generation limit. Below this, you cannot generate. This is megawatt minimum. And more than this, you cannot generate. So this is megawatt maximum. This is the maximum limit. Is it clear, everybody? Just tell me fast. Everybody is comfortable with this? I am having little bit of fever and cough, so today maybe my voice is not that loud. So if you have any problem with the voice or something, you can ask me there and there. See, the next one we have is heat rate curve. Heat rate curve. This heat rate curve is a parabolic curve. It is HI PGI and its unit is mega kilocalorie per megawatt hour. And here you have the power generation PGI. It is a parabolic curve, so it is something like this. So this is the point, operating point, where you are getting the minimum value of the heat rate. How we are defining heat rate? Heat rate basically tells you the information for generating unit power, 1 megawatt hour, 1 unit of power, how much input energy is required. That is called as heat rate. And it is a parabolic curve. It is a parabolic curve. If you see the input energy curve gives you the information that per hour how much input energy is required. Or per hour, the cost is going to be here, cost function is going to be, it is rupees per hour. Per hour, how much rupees are going to spend if this much generation you are going to do at any operating point. Now, if you see this fuel cost curve, input energy curve or fuel cost curve, it is concave upwards. You understand what is the meaning of concave? Concave upwards. Okay, something like this. It is concave upwards. What is the reason? The reason is if you see the slope of the curve, at two extreme points, suppose this point, you see the slope of the curve, and here you see the slope of the curve, then you will see the slope of the curve is increasing. What is the meaning of the slope of the curve increasing? Slope of the curve increasing means that as you are going towards the maximum power generation limit, you have to spend more and more input energy or rupees to generate a given amount of power. Are you getting that? That is why it is, you can say, concave upwards. If you talk about the heat rate curve, you will see both of these points, the efficiency is going to be less. Why? Because more of input energy is required for unit amount of power generation, and this is the point which gives you the maximum efficiency at which you can operate your generator. Good evening everybody. Now settle down. Now this heat rate curve you can approximate with the equation HI PGI as alpha I dash upon PGI plus beta I dash plus gamma I dash PGI, where alpha I dash, beta I dash, gamma I dash, alpha I dash, beta I dash, gamma I dash are constants. For the ith bus, they are the constant, ith generator. Now if you write Fi PGI, from the unit itself you can understand. What is the unit of H? It is mega kilocalorie per megawatt hour. What is the unit of input energy Fi? It is mega kilocalorie per hour. So if you multiply the heat rate with the power generated, you will get the input energy. So you can write it as Hi PGI multiplied by PGI. Just multiply it and see what you are getting. So you will be getting Fi PGI, and this is alpha I dash plus beta I dash PGI plus gamma I dash PGI whole square. This is what you are getting for the input energy, or you can say cost function. Is it clear, everybody? Yes, Raghu, you are right. Now if you write the cost function by using this input energy, suppose you are writing cost function Ci PGI, this is going to be K times Fi PGI. What is this K? This K is going to be the fuel cost. It is going to be rupees per mega kilocalorie. Rupees per mega kilocalorie is going to be the unit of K. So if you write it Ci PGI, it becomes K, or suppose it is Ki. For ith bus I am writing. And what is this Fi PGI? It is alpha I dash plus beta I dash PGI plus gamma I dash PGI square. If you multiply with Ki, it becomes Ki alpha I dash plus Ki beta I dash, this is PGI, plus Ki gamma I dash, this is PGI square. Now I am going to assume that Ki alpha I dash is alpha I, Ki beta I dash is beta I, and Ki gamma I dash is gamma I. So finally you will be getting the cost function as Ci PGI as alpha I plus beta I PGI plus gamma I PGI whole square. This is the final cost function. Is it clear, everybody? I hope it is clear for everybody. Now with this cost function, we can find the incremental cost. What do we mean by incremental cost? We will understand. Incremental cost is going to be DCI PGI and differentiate it with respect to the power generated. So alpha is gone. It is beta I plus 2 times gamma I PGI. This is called as incremental cost for the ith generator, incremental cost for the ith generator. And if you closely observe, this relation is equation of a straight line. Equation of a straight line. Yes or no? So if you plot it, this is PGI and this is DCI, DPGI, then it is going to be approximately a straight line. Suppose something like this. Is it clear, everybody? Good evening, everybody. Settle down. So this point gives you the minimum limit of generation. This is the minimum limit of generation, and this is the maximum limit of generation. Okay. How we are defining the incremental cost, this is important, please understand. Now I am going to give you a very important understanding of the whole idea of economic load dispatch. Okay, and you will understand this incremental cost and its significance. Suppose there is a power system in which there are n number of generators. All these generators are generating some amount of power which is being contributed to the final dispatch of the total load or demand connected to the system. It may be P1 from the first generator, P2 from the second generator, likewise. Now when extra load is going to come on the system, how we are going to allocate this extra load to the n number of generators? This is the optimization problem. If I go to the largest generator and if I ask the largest generator that you are the largest generator, why not you take the extra load? Then there may be a possibility the largest generator will say, already I am taking so much load, why should I increase my load? If you go to a small generator and you say, small generator, you please take the load, then a small generator may also deny the offer. But if you can find a solution where the cost of increasing their generation by 1 unit is same for all the generators, how beautiful it is. If the pain is same, what is the pain? Rupees is spent for increasing the generation by 1 unit. Are you getting that? So what is incremental cost? Let me write it here, very, very important. Incremental cost, rupees for increasing the generation by 1 unit. Yes or no? So if this cost of increasing the generation by 1 unit is same for all the generators, then whatever power you are going to allocate to different generators, they are going to accept it, because the pain is same for everybody. And this is the basis of this whole idea of economic load dispatch. For example, suppose you have 2 generators operating in parallel and you have the incremental cost being defined something like this. Randomly I am giving you some examples, then we will proceed. And this is incremental cost. Okay. Suppose you have 2 generators. This is one generator. This is another generator. So how you are going to find the economic load dispatch optimization? The optimization is found so that the incremental cost is going to be same for both of these 2 generators. Suppose this is generator number 1, this is generator number 2. For this incremental cost, suppose generator 1 is generating P1, generator 2 is generating P2. So total generation or total demand is going to be P1 plus P2 equal to the total demand if losses are ignored. If losses are ignored. Everybody is getting that? How to find the optimization? Simply on a common incremental cost they have to generate. This is the basic idea. Now let me talk about the coordination equation. Coordination equation is going to be applicable when the losses are ignored. When the losses are ignored. Losses ignored, it means what? Losses ignored means whatever power you are generating, sigma PGI I1 to N, all the generators generation must be equal to PDJ. PDJ is the demand or load connected at the jth bus. Is it clear? Where J is going to vary from 1 to M. Some random figure I have taken. The basic idea is the total generation, okay, must be equal to the total demand. This is the basic idea because losses we have ignored. The coordination equation says that the incremental cost for all the generators should be constant and it should be equal to lambda, which is called as Lagrangian multiplier. Lagrangian multiplier. So if you have n number of generators, you can write incremental cost of 1, incremental cost of 2 is equal to incremental cost of n. It must be equal to lambda. Is it clear, everybody? So if the cost function is given, if the fuel cost function is given, differentiate it and equate it, put it to lambda. Yes or no? But it is simple, but there are some important cases on which GATE is going to ask you questions. So be very serious now. Case number 1. Case number 1. What is case number 1? Suppose for the common incremental cost, generator 1 is generating P1 and generator 2 is going to generate P2. And this P1 and P2 is going to meet the total demand PD. Now P1 and P2 both are within the limits of minimum power generation and maximum power generation. This condition has to be fulfilled because you cannot generate less than a certain amount and you cannot generate more than a certain amount. This is the minimum and maximum power generation limits. The power generated by any generator should always lie within this minimum and maximum limits. It should not be breached. Case number 2. If a limit is breached, listen very carefully here now, this is important. If a limit is breached, suppose you are saying for incremental cost, generator 1 is generating P1 and for the same incremental cost, generator 2 is generating P2. P1 and P2 equal the demand. But suppose I am assuming P1 is less than P minimum. What happened? Limit breached. Or P2 is less than P minimum. Again, limit is breached. Lower limit is breached. So what you will do? If P1 limit is breached, then you will fix P1 to P minimum. If this is suppose case number 1, sorry, let me use ABCD. Suppose this is subcase A, this is subcase B. So for A subcase, if the P1 lower limit is breached, then P1 you will be fixing at P minimum. Okay. Then P1 is P minimum fixed. Now P2 will be deciding lambda and P1 will not take part in the economic load dispatch. Whatever generator, if it is breaching the minimum or maximum whatever limit and you fix their generation at that particular limit, then the generator which has breached the limit, it is not going to participate in the economic load dispatch. So you may get a question in which a particular generator is going to breach the limit and they will be asking you what is the lambda. In that case, lambda can only be defined by those generators which take parts in the economic load dispatch, not by those generators which has crossed or breached the limit. Is it clear for everybody? Similarly, you can do the case B also. Suppose P2 has breached the limit, so you will fix P2 to the P minimum. It will not take part in economic load dispatch. Okay. And now P1 is going to be deciding what is lambda. Lambda is being decided by P1. Same is the case you can apply if the maximum limit is breached. Similarly, if P1 or P2 breaches the maximum limit, then respective generation is fixed at the limit and lambda is decided by those generators which does not breach the limit. Which does not breach the limit. Is it clear, everybody? There is a high possibility of this type of question being asked this year, because for last couple of years they have not asked a question from this concept. So there is a high possibility this year you will be getting a question from here. This is my gut feeling. Okay, so 7 stars from my side for 2023 GATE examination. Is it clear, everybody? Let us see the next case. Next case is PD max with economic load dispatch. PD max with economic load dispatch. What does it mean? It means how much maximum power can be delivered if you are going to follow the economic load dispatch. If you are following the optimization, that minimum cost, how much maximum power you can deliver to the load? This is the question. Now please understand. Suppose you have a situation something like this. This is the incremental cost and this is the power generated. Something like this. Suppose this is 1 and this is 2. Yes or no? Now suppose if there is no limitation, no condition for economic load dispatch, then without economic load dispatch, if there is no condition of economic load dispatch, what is going to be PD max? Simply you can write P1 max, P2 max and Pn max, yes or no? All the generators, whatever maximum generation limit they are having, just generate that much power from those generators and add it up. That is going to be the total demand which can be delivered. That is the maximum one. But it is when you are not following the economic load dispatch. Suppose you want to follow the economic load dispatch. With economic load dispatch, what is the condition of economic load dispatch? That the incremental cost must be same for all the generators. Now, this is going to be let me just change it a little bit, little more. If you see, if I take the maximum generation for 1, let's see here, maximum generation for 1, then it is okay. But if I see the maximum generation for 2, then it is not okay for 1. Hello? This point of operation is not going to be possible for generator 1 because the incremental cost is not going to be same. It means I have to lower down. How much I have to lower down? I have to lower down up to this point, because the moment you reach here, now P1 is going to be generating the maximum, but P2 is generating something else, not the P2 max, but something which follows the economic load dispatch. Are you able to follow this or not? Hello? So how I am going to approach this problem? Listen very carefully. What I will do, first I will find IC1 for P1 max. If we go with P1 max, what is the incremental cost of first generator? Then I will find IC2 for P2 max. If you generate P2 max from the second generator, what is the incremental cost? And this I will find for all the generators Pn max. Now for the maximum question, I have to decide the minimum incremental cost, yes or no? Out of 1 and 2, you can decide the minimum incremental cost out of these two as the common incremental cost, yes or no? So I am going to decide the final incremental cost as minimum of IC1, IC2, ICN. Is it clear, everybody? So this is going to be my final incremental cost which all the generators has to follow as per the economic load dispatch. Now I will cross check. For this incremental cost, what is the power generated by P1? What is the power generated by P2? And similarly, what is the power generated by nth generator? Just add it up and your PD max is simply going to be P1 plus P2 Pn. That's it. This is the concept for PD max with economic load dispatch. I hope everybody is okay with this. Only 1 or 2 students are commenting. I don't know why. If you have any doubt, you can ask me number of times if you have any problem. Now let us see the next one, PD minimum with economic load dispatch. Now this I think you all can do very easily. On your own you can do, I think. PD minimum with economic load dispatch. Now you yourself can decide. Just draw the diagram and you will understand. This is incremental cost. This is 1, this is 2. Now again you have to follow the common incremental cost if you have to follow the economic load dispatch. Okay. So what should be the common one? See, if you choose this incremental cost is possible for 1 but not possible for 2 because you are going for minimum, so I am starting with the minimum one, PD minimum. It means you have to go little above. So if you follow this, then this incremental cost is suitable or acceptable for 2 also and 1 also. So out of 1 and 2, for the minimum power generation limit, you are choosing the incremental cost as common, which is higher. So the procedure is going to be same, just a small twist. What is the twist? You will find what is the incremental cost. You will find what is the incremental cost for P1 minimum. What is the incremental cost for P2 minimum for different generators, Pn minimum, and out of this you have to choose the higher one. So you have to choose the common incremental cost as maximum of incremental cost 1, incremental cost 2 up to incremental cost n. Now for this common incremental cost which has to be accepted by all the generators for the economic load dispatch, I am going to find how much power generated by generator 1 P1, how much by P2 and how much by Pn. Just add it up and you will get PD minimum, that is P1, P2, Pn. So just the reverse you have to do. When you are finding PD max, you find IC1, IC2 up to IN for P1, P2, P3, Pmax, and just for maximum you take the minimum of this out of these incremental costs. When you are finding PD minimum, then you take the maximum of the incremental cost. I hope everybody is getting that. What is the meaning of this CC? Okay. Is it clear, everybody? Now let us talk about the losses. If losses are present. If losses are present, then total generation will be equal to total demand plus losses. Losses we are going to characterize by a simple equation. Losses we are going to characterize by a simple equation, that is B11 P1 square, B22 P2 square, 2B12 P1 P2. This is for 2 generators. Generally they will be asking you 2 generators only because it is going to be highly complex if they ask for more than 2 generators. Because when losses are included, it becomes quite difficult to deal with the equations and it becomes really highly calculative. But I will give you a general expression. Okay, that is sigma I 1 to n, sigma j 1 to n, pi bij This is Pj. Follow this formula if you have more than 2 generators. Generally for 2 generators you can remember. (2022) I think, I'm not sure, okay, you have to cross check it. Yes, B1, B222, they are the loss coefficients, okay. You have to cross check it, I'm not sure about it. But it hardly matters what they are asking. Whatever they ask, you must be prepared for that. Yes or no? So when you go outside your home, you always take one umbrella. If it rains, you can open it, you can use it. If it does not rain, you can save yourself from the sunshine. If it doesn't rain and it is not a sunny day, then you can use it as a stick to walk. Yes or no? Just to give you some idea. You should always be prepared. You should not judge the examination. So these B11, B22, B12 are loss coefficients. You can see the actual derivation part, okay. Already in some of the session I have discussed, otherwise you can see the book derivation. Are you getting that? Now, if you are talking about the losses, then you have to talk about the exact coordination equation. Exact coordination equation. Exact coordination equation I am defining as incremental cost for the ith generator multiplied by the penalty factor is equal to lambda. Initially it was incremental cost for ith generator is equal to a constant. Now we have included a penalty factor. What is this penalty factor? I am going to tell you. This penalty factor we are defining as Li, we are defining as 1 upon 1 minus del PL upon del PGI. This is what we are defining as penalty factor. What is this del PL upon del PGI? Incremental transmission loss. Incremental transmission loss, ITL, for the ith generator. What is the meaning and significance of incremental transmission loss? It is given as del PL upon del PGI. Del PL upon del PGI. So it simply gives you that if you are increasing your generation by unit, 1 unit of power you are generating more, then what is the amount of loss which is going to occur extra as the extra loss? Yes or no? So this is what we define as incremental transmission loss. So if you write it, you can write it as incremental cost multiplied by penalty factor is equal to lambda, or you can write it incremental cost 1 L1 is equal to incremental cost 2 L2, incremental cost n multiplied by Ln is equal to lambda. If you write actual equation, it becomes dC1 dP1 multiplied by 1 upon 1 minus del PL upon del P1. If there are 2 generators only, I am writing because it becomes very lengthy. So it becomes dC2 dP2 1 upon 1 minus del PL upon del P2 is equal to lambda. Everybody is comfortable with this? I hope it is clear. Now you understand one thing, what is the significance of this penalty factor, why you are calling it a penalty. Without losses, lambda is incremental cost of any generator. With losses, what is lambda? You tell me. With losses, what is lambda? It is incremental cost into L1. Incremental cost into L1. It is incremental cost into L1, Li, sorry. Now you understand, lambda is what? Lambda is basically rupees per megawatt hour, yes or no? For generating 1 unit of power, how much money is spent? That is lambda. So this is equal to this. But when losses are included, you are multiplying it by some factor. Now this factor is 1 upon 1 minus del PL upon del PGI. Del PL upon del PGI is going to be some value, obviously less than 1. Yes or no? It cannot be negative. So 1 minus something which is less than 1 is going to be a value which is less than 1. Now if it is going to have a value which is less than 1, if this value comes out to be a value which is less than 1, then this Li is going to be greater than 1. If Li is greater than 1, it means you have to pay more. You have to pay more rupees per megawatt hour. And this is true. You have to pay for the losses. Common sense, you have to pay for the losses. If this is clear for everyone, then I think now we can go to the questions. If this much is clear for everybody. We'll go step by step. First, we will do some basic questions so that you understand the concept well. So guys, everybody is okay with that? So shall we go to the questions? This much is okay for you. The heat rate of a 50 megawatt fuel fired generator unit is measured as follows: 25% of the rating, 10 megakilocalorie per megawatt, 40% of, it should be hour, na? It should be hour also. Just add hour also. %40 of the rating, 8.6 megakilocalorie per megawatt hour, this. Cost of a fuel is given as 4 rupees 4 per megakilocalorie. He is asking calculate the cost of the fuel to deliver 51 megawatt. So basically you have to find the cost function. Okay. How to do this? He is talking about heat rate. So I have to write the expression for heat rate. What was the expression? Do you remember? Alpha I dash upon PGI plus beta I dash plus gamma I dash PGI. This was the approximate equation for representing the parabolic equation for heat rate. Now he is giving you 3 conditions. Just put the 3 conditions, because basically we have to find alpha I dash, beta I dash, gamma I dash. So in the first case he is saying the heat rate is 10 megakilocalorie per megawatt hour. So this is 10 equal to 25% of the rating. What is the rating? The rating is 50 megawatt. So 50 megawatt, what is going to be 25%? So it is 12.5. So PG is 12.5 for first case. So it is alpha I dash upon 12.5 plus beta I dash plus gamma I dash, this is 12.5. Second, 8.6 megakilocalorie. So 8.6, okay. This is alpha I dash divided by, this is 40% of the rating. So 50 into 40, 100. So it is 20. So this is 20. Beta I dash, gamma I dash, 20. Third case, 100% of the rating, 8 megakilocalorie per megawatt hour. So this is 8. This is alpha I dash. Now it is 100%, so 50. Plus beta I dash plus gamma I dash 50. Is it clear, everybody? So simultaneously you have to solve these three equations. This type of question is not going to be asked in your GATE examination. Be very clear. But this question includes 10 questions. So if you can get a command or confidence over this question, you can get confidence for 10 types of questions. So I am just giving you the values because I have the reference, because it will take a lot of time to give you the exact, solve it manually. So alpha dash you must be getting, please cross check it. Alpha I dash you must be getting 55.56. Beta I dash you must be getting 5.11. Gamma I dash you must be getting 0.03, 0.0355. Alpha, beta, gamma. Once you get alpha, beta, gamma, half of the job is done. So you can write HI as 55.56 upon PGI plus beta is 5.11 plus gamma is 0.0355. This is PGI square. If you want to write the input energy from here, you can write Fi. This is going to be Hi multiplied by PGI. So it becomes 55.56 plus 5.11 PGI plus 0.0355. Sorry, it is not PG square, it is simply PG, okay. It is simply PG. Now it will be PG square. Is it clear? But you are not supposed to find the input fuel. You have to find the input, cost. Yes or no? So for writing the cost function, you have to multiply this input fuel with the cost of the fuel, rupees 4 per mega kilocalorie. So multiply by 4. Just multiply this and you will be getting the cost function. I am writing it finally. As per my reference, I am writing it finally. You cross check it later on. You must be getting it as 222.4 plus 20.44 PG plus 0.142 PGI square. Are you getting this? Now simply he is asking, what will be the cost of the fuel to deliver 51 megawatt of power? Just put PG is equal to 51. So C cost for 51 megawatt is going to be 222.4 plus 20.44 into 51 plus 0.142 into 51 square. Just solve this and you will be getting as per my reference 1634. rupees 1634 per hour. Is it clear for everybody? Okay. See the next question. The incremental fuel cost equations for the two generating units are given as this. The upper and lower limit of power generation is 20 megawatt and 12. It should be 125. Okay. Just correct it. It should be 125. It cannot be 12.5. 125. Upper and lower limits are 125 and 20 megawatts respectively. He is asking you to calculate P1 and P2 if the load demand is 40 megawatt, 250 megawatt and 150 megawatt. There are three cases for which you have to find P1 and P2. Let us take the first case when the total demand is 40 megawatt. 40 megawatt. Okay. Now if you observe the minimum generation is 20 megawatt. So both the generators, you just generate 20 megawatt directly, either you can do, yes or no. Or what you can do is apply the coordination equation. Incremental cost directly mentioned. Sometimes it is given as C1 upon dC1 upon dP1. Sometimes it is dF1 upon dP1. It's a different nomenclature used by different books, so don't get confused. The only thing you have to understand whether it is the increment or the total value. That's it. If it is a total value, it is going to be a quadratic equation. If it is the incremental one, it is going to be a straight line. So you can identify. So from the coordination equation, you can write dF1 upon dP1 is equal to dF2 upon dP2. It is 0.1 P1 plus 20 is equal to 0.12 P2 plus 16. This is equation number 1. And the second equation is P1 plus P2 is equal to 40. Just solve these two equations and tell me what is the value you are getting for P1 and P2. Just solve it. I am telling you from my reference. So if you solve these two equations, okay, now you know that this is not possible because you cannot generate screen gaya. You cannot generate less than 20 megawatt, yes or no? So the moment P1 is breaching the limit, you will fix, because P1 is less than 20 megawatt, you have to fix P1 to 20 megawatt and P2 is going to be 20 megawatt. Total demand minus 20, 40 minus 20. Now P1 you have fixed because it has crossed the limit, breached the limit. So lambda is going to be decided by which? Lambda will be decided by this, P2. P2 will decide lambda. So what is going to be lambda here, you tell me. Lambda is the incremental cost, you have to decide by the second generator. Second generator is this. So this is lambda is 0.12, P2 is 20 plus 16. Just solve this, you will get the lambda. Lambda also. Now let us take the second case, 250 megawatt. If you go for 250 megawatt, PD is 250 megawatt. Again same thing you have to do. You will get the same equation. dF1 upon dP1 is equal to dF2 upon dP2, just put the values, 0.1 P1 plus 20 is equal to 0.12 P2 plus 16. This is equation number 1. Second equation, P1 plus P2 is 250. If you solve this for the economic load dispatch, from my reference I am telling you, you will be getting P1 as 118.18 megawatt and P2 as 131.81 megawatts. 131.81 megawatts. Now P2 is going to breach the upper limit. It is not possible. Beyond 125 you cannot generate. So P2 you have to fix to 125 as the maximum limit of generation. Then P1 is going to be total demand minus P2. So it is 250 minus 125. So it also becomes 125 megawatt. But the important thing is lambda will be decided by P1. P1 will decide lambda, not P2, because P2 will not take part in the economic load dispatch. So what is going to be lambda now? Lambda will be decided by P1. So P1 equation is 0.1 P1. 0.1 P1 is 125 plus 20. So you can find it. Now see the third case. PD 150 megawatt. PD 150 megawatt. Now 150 megawatt, again P1 plus P2 is 150, say equation number 1, and 0.1 P1, I am just writing the dF1 upon dP1, same equation, is equal to 0.12 P2 plus 16 as equation number 2. Find P1 and P2. So as per my reference, you will be getting P1 as 63.636 megawatt and P2 as 86.363 megawatt. Okay. So now whether you use P1 or P2 to find lambda, it is going to be same. You can cross check. 0.1. What is P1? 63.636 plus it is 20. It will be same as 0.12 into 86.363 plus 16. Whatever you use, you will get the same value. The reason is now both the generators are taking part in the economic load dispatch because no generator is breaching the limit between 20 megawatt to 125 megawatt. So these questions they are not going to ask you in the examination, but they give you a clear base understanding of the concept. Now you can go for next questions. This question asks you the concept of PD max. Now how to do it? You remember? When you go for PD max, for P1 and P2 max, find the incremental cost. Now what is incremental cost? 1. For the first generator, if it is 125, so it is 0.1 into 125 plus 20. Just solve it. It should be 32.5. What is incremental cost for the second generator if it generates 125? That is the maximum power. It is 0.12 into 125 plus 16. Just solve this and tell me what you are getting. You must be getting, I think, 30. It's okay, Raghu. I think you must be getting 31. Okay. 31. Because it is max, so you have to choose the reverse, minimum of. So final incremental cost is going to be minimum of incremental cost 1 and incremental cost 2. So what is the minimum of 32.5 and 31? Obviously 31. So 31 is the common incremental cost for both the generators. Now for 31 incremental cost, P2 you know what is. P2 is going to be 125 because it decides the incremental cost. What is P1? See very carefully. What is P1? If the incremental cost is 31, so it is 31 minus 20. It is 31 minus 20 divided by 0.1. So it is 11 upon 0.1. So it is 110 megawatt. So what is the PD max? P1 plus P2. So it is 235 megawatt. Is it clear, everybody? 235 megawatt. Are you able to follow this? How to approach these type of questions? I think you guys don't require these type of sessions because I can see the strengths going down. I thought every year you are getting 2-3, minimum 2 questions, so you are getting 1 or 2 questions, around 2 to 4 marks. So let us do it. But I don't see enthusiasm, only one candidate responding. Now see, this question talks about the saving in the two cases. If you follow the economic load dispatch, what is the saving in comparison to when you are getting equal sharing? Equal sharing means half of load you are giving to the generators. How to do this? Suppose you are going for equal sharing. So for equal sharing, P1 plus P2 is equal to 300 will give you P1, P2 both equal to 150. That's it. Are you getting this or not? But when you go for economic load dispatch, listen very carefully. Again, P1 plus P2 is 300, but at the same time, you have to follow one more condition, that is the coordination equation. The incremental cost has to be same. So 0.1 P1 plus 20 is equal to 0.12 P2 plus 15, equation number 2. Just solve these two equations. You will get P1 and P2. So P1, P2 you will be getting, you please confirm it. P1 you will be getting 140.91 megawatt. And P2 you should be getting as 159.09 megawatt. Now you see, one generator you are generating less than equal sharing, and one generator you are generating more than equal sharing. It means P1 you will be getting the saving and P2 you will be getting the expenditure. So how you write the saving? What is the net saving? What is the net saving? Saving minus expenditure. What is saving? For the first generator equation is 0.1 P1 plus 20 dP1, 140.91, and this is 150. This is the amount of saving. Directly you can write amount of saving minus expenditure. Expenditure is in the second generator. Second generator is 0.12 P2 plus 15. This is dP2, and P2 is going to range from 150 to 159.09. Just this you have to solve. Okay, if you know the concept of saving and expenditure, you can find it. Solve it. I think as per my reference, you must be getting 9.091 rupees per hour. Is it clear, everybody? You understand the point or not? How easy it is. It's not a lengthy problem. You simply identify for which generator you are getting the saving, for which generator you are getting the expenditure. So net saving is going to be saving minus expenditure, total saving minus total expenditure. See the next question. Consider a two-plant system. The entire load is connected to plant number 2. Listen very carefully. Whenever you find this type of a statement, what is the idea? This is one generator. This is another generator. This is generator number 2. This is generator number 1. Total load is connected to generator number 2. Total load is connected to generator number 2 or bus number 2. Now, whatever power, real or reactive power is sent, that is going to travel. Yes or no? That is going to travel from generator 1 to generator 2 because load is connected to 2. But for generator 2, there is no need for the power to travel over the line because the load itself is connected to generator number 2. So transmission losses because of the power supplied by generator number 2 to the load is going to be 0. So in this case, all loss coefficients related to the bus at which all the load is connected is 0. Is R0. What does it mean? It is a two generator system. You are saying all the load is connected to generator number 2, plant number 2. It means, sir, B22 is 0 and B12 is 0. So what is the loss? Loss is going to be B11 P1 square. But he is giving you one information. The plant number 1 supplies 100 megawatt for a corresponding transmission loss of 5 megawatt. So you just put, you will get the value of loss coefficient B11. So he is saying loss is 5 megawatt. And what is the power generated? Supplied 100 megawatt. So you are getting B11 as 5 into 10 to the power minus 4. This is B11. This is B11. He is saying lambda is this much. He is asking find the optimal generation. When losses are included, you have to write the exact coordination equation. That is dC1 upon dP1 1 upon 1 minus del PL upon del P1 is equal to dC2 dP2 1 upon 1 minus del PL upon del P2 is equal to lambda. The only thing now you have to find in this equation is the value of incremental transmission loss for generator 1 and generator 2. If this is your loss equation, if the loss equation is B11 P1 square, what is going to be del PL upon del P2? It is 0. What is del PL upon del P1? It is going to be 2 times B11 P1. Yes or no? It is 2 times B11 P1. Just put all these values. Put all these. Can you put it or not? What is dC1 upon dP1? dC1 upon dP1 is given in the problem. This is dC1 upon dP1. So it is 0.01 P1 plus 10. This is dC1 upon dP1. 1 upon 1 minus del PL upon del P1 is 2B11 P1 is equal to dC2 upon dP2, dC2 upon dP2, 0.02 P2, 0.02 P2 plus 12. Penalty factor is not there. Why? Because this is 0, na? This is 0. When this is 0, it is 1 upon 1, simply this is equal to lambda. And lambda is given as 15. So can you find P1 and P2? Yes or no? P1, B11, you know, loss coefficient. P2 directly you can find. So if you solve this as per my reference, I am giving you the values. You can cross check it later on as your homework. Understand the logic now. P1 you must be getting as 200 megawatt and P2 you should be getting as 150 megawatt. Is it clear, everybody? Any doubt you can ask me. See the next question, it is a similar question. Consider a power plant consisting of two generators having this incremental cost. A transmission loss of 10 megawatt is incurred when 100 megawatt is transferred from bus number 1 to bus number 2. Total static load is connected on bus number 2. Find P1 and P2 for economic load dispatch. It is a similar problem when losses are included and coordinated. Now this is a concept. Let me tell you what is this concept. Losses included, okay, and coordinated. What does it mean? If this is written, then you have to follow this exact equation. dC1 dP1 1 upon 1 minus del PL upon del P1 is equal to dC2 upon dP2 1 upon 1 minus del PL upon del P2 is equal to lambda. Okay. And losses included means, listen very carefully, P1 plus P2 should be equal to P1 plus P2 should be, this is the total generation, total demand plus total losses. So this is called as losses included and this is called as losses coordinated. Are you getting that? Sometimes you will find this written, losses included, but not coordinated. If this is written, then you will simply write P1 plus P2 is equal to PD plus PL, but you will follow the coordination equation, not the exact coordination equation. dC1 upon dP1 is equal to dC2 upon dP2 is equal to lambda. This is the approach. Is it clear? I hope it is clear. So the question belongs to the first category when losses are included and coordinated. Okay, one time this type of confusion was there when a question was asked in the engineering services examination. So I am telling you beforehand. Again, very easily you can understand the PL equation is going to be B11 P1 square, as B22 and B12 are going to be 0 as total load is connected to bus number 2. Now, he is saying when 100 megawatt is sent, 10 megawatt is a loss. So, from here you can write B11 100 square. So, it is B11 10 to the power minus 3. So, what is going to be del PL upon del P1? It is 2 times 10 to the power minus 3 P1, and what is del PL upon del P2? It is going to be 0. Yes or no? Now, in this case, lambda is not going to help you because lambda is not given. So, you have to solve two equations. dC1 upon dP1, 1 upon 1 minus del PL upon del P1 is equal to dC2 upon dP2. Now, penalty factor will be 1 because all the losses, all the loads are connected to bus number 2 only. So, this should be equal to lambda. This will be your equation number 2, equation number 1, and equation number 2 is going to be P1 plus P2 is equal to PD plus PL, that is the losses. So, it is going to be little lengthy for you to solve it, but I hope you understand the logic. You can do it. If you want the answer, I can give you the answer so that you can do it later on. You want it? So, as per my reference, you must be getting P1 as 135.88. 135.88 megawatts. What is P2? 142.58. 142.58 megawatt. Is it clear, everybody? Let us see this question. Incremental cost of 3 plants are given as, so there are 3 plants, but not to worry. It's an easy question. Where P1, P2, P3 are the output in megawatt, find the optimum load allocation when the total load is 242.5 megawatt. What is the total load? 242.5. 242.5 megawatt. Okay. So, all these incremental cost has to be same. Suppose this is equal to lambda, this is equal to lambda, and this is equal to lambda. Yes or no? So, can I write P1? Just see here. Can I write P1 as lambda minus 160 upon 0.8? Yes or no? Can I write P2 as lambda minus 120 upon 0.9, and can I write P3 as lambda minus 110 divided by 1.25? If yes, then just write P1 plus P2 plus P3 is equal to 242.5 and find what is lambda. Let's put this. Yes or no? So, lambda minus 160 divided by 0.8 plus lambda minus 120 divided by 0.9 plus lambda minus 110 divided by 1.25, 242.5. Just find what is lambda. As per my reference, you must be getting lambda as 210. You must be getting lambda as 210. 210 rupees per hour. Sorry, rupees per megawatt hour. Rupees per megawatt hour. Now, if you know lambda very easily, you can calculate what is P1, what is P2, and what is P3. So, first calculate P1, P2, P3 from these equations if you know lambda. So, P1 you will be getting, you solve it, I am just writing it from the reference, 62.5 megawatts. 62.5 megawatts. P2 is 100 megawatt. P3 is 80 megawatt. So you must be getting P1, P2, P3 for optimal scheduling this. But this is not what he is asking in the question. He is introducing a new concept, that is the participation factor. I will tell you what is participation factor. First, I will tell you how it is calculated. Participation factor, you will be using the inverse of this factor. Inverse of this factor to decide how much demand is going to be allocated to which generator. This is one method, one way of doing it. So how, suppose we are defining the participation factor. Participation factor as for first generator it is K1. So it is going to be inverse of 0.8. So it is 1 upon 0.8. Just add all the inverse of these factors. So it is 1 upon 0.8 plus for second generator it is 0.9. 1 upon 0.9 plus 1.25. 1.25. Similarly, you can find what is K2. K2 becomes 1 upon 0.9. This is 1 upon 0.8. 1 upon 0.9 plus 1 upon 1.25. Similarly, you can find K3, participation factor for the third generator, that is 1 upon 1.25 divided by 1 upon 0.8, 0.9, 1 upon 1.25. Just solve these K1, K2, K3. Okay. K1 you must be getting 0.3954. 0.3954. K2 you must be getting 0.3515. 0.3515. And K3 you must be getting 0.2531. 0.2531. Once you have the participation factor, what is the total change in demand? Total change in demand is given. He is saying using participation factors determine the optimal scheduling when the load increases to 250 megawatts. So suddenly from 242.5 you have increased to 250. So total change is going to be 250 minus 242.5. So it is how much? 7.5? Yes or no? So what is going to be the incremental power at generator 1? It is going to be participation factor for generator 1 multiplied by total change in demand. Change in power generation at generator 2 is participation factor multiplied by total change in power demand. For generator 3 it is K3 multiplied by delta PD. Just put the values as for my reference. It is 2.9655 megawatt. For generator 2 it is 2.6363 megawatt. For generator 3 it is 1.8982 megawatt. But this is not the final answer. He is asking P1. So P1 is going to be what? The previous value of P1 plus, or you can write it as P1 dash plus delta P1. What is P2 dash? P2 plus delta P2. Then what is P3 dash? It is P3 plus delta P3. I think all of you can do it. Is it clear, everybody? Now, if you see the cost function, let me use, just give me a moment, let me add one page here. So, if you see, the cost function is given as, cost function was given as alpha I plus beta I. This is PGI plus gamma I PGI square. If you see the incremental cost, it is given as beta I plus 2 gamma I PGI. Okay. So this is called as incremental cost, which is nothing but lambda as per the economic. See, it's a mathematical tool basically. Most of the time you are not doing these calculations manually, you are doing these calculations through a logic, through a system, through a flow chart, through a computer. So that is why this method is important when you are dealing with the computers. Okay. So what I was saying, yes. Now for a small change, okay, for a small change, delta lambda upon delta pi, delta lambda upon delta pi, this is going to be what? 2 gamma I. Beta is going to be cancelled. So now you see this delta lambda upon delta pi, you can use, there is a derivation, so I am not going to the derivation. So actually when you are writing the participation factor, it is coming as 1 upon 2 times gamma I upon sigma 1 upon 2 times gamma I. Okay. So this 2 you can easily remove. That is what we have done in the problem. When we are finding the participation factor, we have simply taken the inverse of this factor. Yes or no? We did not introduce 2, but for understanding purpose. Anyways, let us go to this problem. I think this problem now what we have done till now is the problems. What I found is are important to understand the concept. Now, these are the problems which actually come in your GATE examination. Some previous year GATE problems I have taken, just see how you can do it. Incremental cost curve in rupees per megawatt hour for two generators supplying a common load of 700 megawatt are shown in the figure. The maximum and minimum generation limits are also indicated. Optimum generation schedule is, total is 700. Now see here, for economic load dispatch there must be a common incremental cost. It is ranging 450 to 600. This is 650 to 800. What is incremental cost? The money is spent on increasing the power generation by 1 unit. So if you see, there is no common point, no incremental cost which is common for both the cases. So what we will do, maximum how much we can generate with this, because this is less costly. Its maximum incremental cost is 600 and its minimum incremental cost is 650. So how much maximum you can generate from this generator? You generate A. So that is possible is this point, that is 450. So 450 you will be generating from generator A and rest 250 by generator B. So what is the correct option? C. See this question, the incremental cost of operating two generating units are mentioned as this. So the equation of incremental cost is given. Minimum and maximum power generation limit is also mentioned. Now for a certain load, he is not mentioning the load directly, he is giving you indirectly what is the total demand, and that you have to find from these incremental costs. Are you getting this? By using these equations one by one. For the given load demand, suppose I am assuming generator 1 generates P1, generator 2 generates P2. So P1 plus P2 is going to be the total demand. How you are finding P1? Just see here. This incremental cost is for generator number 1. Actually, this belongs to this generator, this belongs to this generator. Reverse it is written. So dC1 upon dP1 given 76, put 76 here. So 76 minus 50 upon 0.2. So 76 minus 50 upon 0.2. Just tell me what you are getting as P1. What about P2? It is 68.8 minus 40. 68.8 minus 40 divided by 0.24. Just solve this also. So what you are getting as P1 and P2 is going to be, yeah, good evening Payash. Just solve this, you will be getting your PD. How much you are getting, just tell me. Otherwise, I have to check the reference. So you must be getting P1 as 130 megawatt and P2 as 120. This is the demand for the given. How much you are getting? 280. Please do the calculations carefully. Okay. So total you must be getting 250 megawatt. It is coming as 250. So once you get P1, P2, 250. Now this is not final P1, P2. This is for the demand. In order to find the total demand, you have used this P1 and P2. Okay, because he is not giving you the total demand directly, he is giving you the incremental cost. Now you have to follow the economic load dispatch. Minimize the cost means follow the economic load dispatch. It's okay, no problem. Now you have to follow this. So it is 0.2 P1 plus 50, 0.2 P1 plus 50 is equal to 0.24 P2 plus 40, 0.24 P2 plus 40. This will give you one equation, and P1, P2 you have just found, total equal to 250. Equation number 1, equation number 2, you have to solve it, and for economic load dispatch minimum cost, you will be getting what is P1 and what is P2. So P1 is 113, sorry 113.636 megawatt. What is P2? 136.36 megawatt. So what he was asking in the question, he is simply asking P2. So you know what is P2, 136.36. Is it clear, everybody? So I think now you all are going to master the economic load dispatch. You all can do it. So finally we came to the conclusion part of this session. I hope you enjoyed it. One important information about the GATE and Engineering Services test series, where you are getting the unlimited access. That is the full-length mock subject-wise test. The link is given in the description. You can follow it. Some of the important features of this test series is 60 plus tests covering GATE and EAC, detailed mock analysis, virtual scientific calculator, 4,000 plus practice questions, all India open mocks curated by the GATE experts. So this is all from my side, friends. Thank you so much for joining me live in the discussion. I hope you enjoyed and learned a lot, and I hope you will get at least some advantage in the real GATE examination. Thank you so much. Stay connected. Thank you. Take care.